Hello, everyone, and welcome to this algebra video. In this one, we're going to be talking about solving both linear and absolute value inequalities. I'm going to talk about the linear inequalities first, do a couple problems, and then we'll move on to the absolute value inequality. So we'll start with these guys, the linear inequalities. Before we talk about that, let's talk about the word inequality. So most of what we do in algebra, when the topic of the problem is to solve for something, most of what we do is we work with equations, we work with equal signs. But if you compare two numbers, let's say A and B could be any real numbers. Well, one possible relationship is that these two numbers can be equal to each other, right? 5 equals 5, or 0.5 equals 1/2, right? We could also have that the first number is not equal to the second number. But we also have two other possible scenarios. We could have that the first number is larger than the second number. Or we could have the first number is smaller than the second number. So these last two, we refer to these as inequalities. Technically, that also includes the not equal to sign, but we're going to ignore that for now because it's not relevant to this topic. So we're going to focus on just the greater than symbol and the less than symbol. It's actually the same symbol. It just has two directions. Basically, the open side points towards the larger number. So in this case right here, A is the bigger number. In this case, at the bottom, the B is the bigger number. Okay, so there's two fundamental differences between equations and inequalities. The first one is what the solution looks like. Generally, when we have an equation, for example, 2 minus 3x is equal to 17. Right, there's an equation. For linear equations, we get one answer, one single answer. So if we were to solve this for x, we could subtract 2 from both sides. Right, that would eliminate this positive 2, leaving a negative 3x on the left and a 15 on the right. Now we want to get x by itself, so we could eliminate that times the negative 3 by dividing by negative 3 both sides. That would eliminate the times 3 with a divide by 3, and we end up with x is equal to negative 5. So negative 5 is the only number, the only real number that if we were to plug it in, actually right here, if we were to plug it in for x, we would get 17 on the left. We would get a true statement, 17 equals 17. So an equation, specifically a linear equation, has one answer, one solution. Other types of equations have more, quadratics or polynomials or other types of equations have more, but we're sticking strictly with linear. Linear means the x is raised only to the first power. Now, let's replace that equal sign. We switch to a different color. Let's replace that equal sign with a greater than sign. 2 minus 3x, not equal, greater than 17. So in the first case, the equation up here, this is a mathematical statement that's saying 2 minus 3 times some number is exactly equal to 17. Okay. Now down here, what this is saying is that x can be any number. X could be any number such that if you plug it in, so if you replace this letter x with a number, if you get anything on the left larger than 17, any number, then x is a solution. Now we would solve for x using the same steps. We would subtract 2 from both sides. then we would divide both sides by -3. We would isolate our x, we would get an x on one side and a -5 on the other side, just like we did with the equation. So we do a -2, a -2. The -2's cancel. We've got a -3x is greater than 15. And now we would divide by -3. Now this is the second. I mentioned there's two fundamental differences. The first being with an inequality, you have infinitely many solutions. X could be any number that gives you something larger than 17 on the left, any number. So you have infinitely many solutions. Now, the second difference is that the inequality symbol, the direction matters. If you replace this symbol with this symbol, it means something different, right? So the direction matters. With an equal sign, if you flip an equal sign, it's still the same statement. So the second difference is if you divide or multiply both sides of the equation, if you multiply or divide both sides of the equation by a negative number, like we do here, we divide by -3, divide by -3, just like we did in the equation, just like we did up here. If we divide our inequality by a negative number, and this goes for multiplication as well, we have to change the direction of the inequality symbol. So if -3x is greater than 15, then when we divide by -3 both sides, x is less than -5. X is less than -5. Now, why is this? Why? Why do we have to change the direction? I don't want to just say, if you multiply or divide by a negative, you have to change the direction. Just memorize that and use it. Well, let's look at a specific example. I'll give you two numbers, 50 and 30. Now, one of these numbers is larger. Well, it's the 50. It's not a trick question. There's nothing elaborate going on here. 50 is bigger than 30. So for positive numbers, if you think about the number line with 0 in the middle, here's 0. For positive numbers, the number that's farther away from 0 is larger. 50 is over here, and 30 is over here. 50 is further from 0, so 50 is a bigger number, okay? But if we change the sign, let's say I multiply both of these numbers by -1, so -50 and a -30. Well, now which number is bigger? Well, for negative numbers, the one closer to 0 is actually the larger number. Right on the number line, if there's two numbers and they're different, the number on the right is the larger number. 50 is larger than 30. -30 is larger than -50. So we have to change that direction. Because for negative numbers, farther away from 0 means smaller. For positive numbers, farther away from 0 means bigger. Right? So this is why when we're solving, now we're going to take the same steps. We're going to take the same steps in solving inequalities as with solving equations. You could add something to both sides. You could subtract something from both sides. You could multiply both sides by a number. You could divide both sides by a number. As long as you do the same thing to both sides. The exact same is true for inequalities. With one addition to that. If you multiply or divide both sides by a negative number, you have to change the direction of the inequality symbol. Okay, so let's look at a couple of problems. We've got 9x minus 14 is less than or equal to, so now we have two symbols together, less than or equal to 6x minus 15. So other than a no solution set, use interval notation, which we'll talk about in a moment. Interval notation, didn't want to do that. I want to highlight that. Interval notation to express the solution and then graph the solution set on a number line. I'm actually going to graph first and then do interval notation, but I'm still going to do both. So we want to get all of our x's to one side, a number on the other side, just like with equations. Okay, so we could start off by subtracting 6x from both sides. If we subtract 6x from both sides, that cancels off the x's on the right. So positive 6x, negative 6x cancel, leaving us only x. X is on the right, x is on the left-hand side. So we have 3x, 9x minus 6x. We've still got a minus 14 is less than or equal to a negative 15. Our goal is to get x by itself, so we could add 14 to both sides. It's taking us one step closer to isolating the x. Add 14 to both sides. That'll cancel those two numbers. They'll cancel the negative 14 or the minus 14, which is what we want. Okay, so we still have 3x is less than or equal to 15 minus 14 is negative 1. Now, finally, we have 3 times x. So to eliminate times 3, we can divide both sides by 3. Notice we're getting progressively simpler with each step. Our goal is x by itself on one side, number on the other side. So now we have x is less than or equal to negative 1/3. We didn't change the direction of the symbol, right? At no point, we never multiplied by a negative. We never divided by a negative. So there was no need to change the direction. So this statement is saying x is less than or equal to. So that's a combination. If we take the equal to symbol and the less than symbol and combine them into one, it's less than or equal to. Right? X is any number that is either equal to negative 1/3 or is less than negative 1/3. So if we look at the number line, I'll do number line before interval notation. So zeros in the middle, positive numbers to the right. So this number line, these arrows at the end indicate that these numbers go on forever, infinitely in the positive direction. So we use the infinity symbol to say, okay, these numbers go on forever in the right, in the positive direction. And then negative infinity on the left-hand side, the negative numbers. So it would be -1, -2, -3, and so on. I actually don't want to use those tick marks because we have a fraction. The negative numbers go on forever in the left. So our answer is, I'll just say negative 1/3 is right here, somewhere to the left of 0. It's a negative number. So what does this mean? Less than or equal to negative 1/3. And that's how we're reading this. X is less than or equal to negative 1/3. That means x, I'll use green for the solution, x could be any number down here. And we keep going. Any number down to negative infinity, or in the direction of negative infinity. Negative infinity is not a number. That's the less than part, right? Also, x could be equal to negative 1/3. So we denote that with a shaded dot, and a shaded in dot. If there was no equal to sign there, we would use an open circle. We would say, okay, open circle, and then we would shade everything to the left. But in this case, we have an equal to sign, so we'll shade in that dot. And so now visually, this is basically a picture of the answer. A graph is a picture of something, right? This is a graph, this number line. Interval notation. Interval notation. We use one of these two symbols. A square bracket means including this number. So for example, we're going to include the negative 1/3 as part of our answer because it's x is less than or equal to. So if there's an or equal to, we want to include that number. If we don't have the or equal to, we don't want to include that first number or that last number. So we use a parenthesis, a curved parenthesis, to say not including this number. Not including this number. And then interval notation. We're basically listing the starting point or the starting value, comma, the ending value. Now, we're looking left to right on the number line. Well, there is no starting number because this arrow goes on forever to the left. So since there's no starting number, we would say, okay, starting with negative infinity, that's not a number. That's more of a concept. So in the infinity or negative infinity symbol always gets a curved parenthesis. And then the solution set ends, we're looking left to right now, left to right, ends at the number negative 1/3. And we're going to use a square bracket to say the negative 1/3 is also part of our solution. All right, so this is 3 ways of saying the same thing. This is number 1, giving the answer as an inequality. Number 2, giving the answer as a graph. Number 3, giving the answer as an interval. 3 ways of saying the same thing. This is something hopefully you've seen before, 3 ways of saying the same thing. I could say 1.5, I could use a decimal, is the same as 1.5. I could use a mixed number, which is also the same as 3/2. I could use an improper fraction. So that's 3 ways. 3 ways of saying the same thing. All right, so same thing here. Inequality, graph, or interval notation. Now with inequalities, it's possible you may have 2 of them in one problem. With an equal sign, you only have 1. It's the left side equals the right side. But with inequalities, and let me go on to number 2, you may have what's called a compound inequality, where you've got not just a left side and a right side, but you've got a middle. Oh, that's not the right side. The one would be the right side. The rule is the rule, just like with equations or inequalities where there's one symbol. Whatever you do to one side, you have to do to the other. In this case, others, plural. There's 3 sides. There's the left, the middle, and the right. You could do anything you want, add, subtract, multiply, or divide, as long as you do it to all 3 sides, all 3 parts. This one's going to be just a one-step problem. We want to get x by itself. And we could do that by adding 2. If we add 2, the -2 and the +2 cancel. And that gives us x by itself. Whatever we do to the middle, we got to do to the left and the right. So if we add 2 in the middle, we got to add 2 also to the left and the right. We have -9 plus 2. That'll be -7. 1 plus 2 will be +3. So x is between -7 and 3. X is between -7 and 3. But also, x can be equal to -7, but not equal to +3. So if we look at the number line, say -7 is over here somewhere, and 3 is maybe over there somewhere. So x is any number between them, right? Infinitely many numbers. All the whole numbers, all the fractions, all the decimals, all the irrational numbers, every real number between -7 and 3. But x is also, in addition to those numbers, x is also equal to -7. So we would use a closed circle here, closed circle. And since x is not equal to 3, is strictly less than, just less than, not less than or equal to, we use an open circle at the 3 to say, okay, x could be equal to -7. X could be equal to any number between -7 and 3, but x could not be equal to 3. So using interval notation, our answer starts with -7, ends with 3. Okay? We use a bracket on the -7 and a curved parenthesis on the 3. So that would be our answer in interval notation. So now, let's take what we've just talked about and apply it to the next topic, which is still solving inequalities, but in this case, inequalities that have to do with or contain an absolute value symbol. So before we do a couple of problems, I have 2 problems I want to do. So absolute value inequalities. Let's talk about absolute value first, and then we'll talk about how that connects with the inequalities. So absolute value, the absolute value of a number is the distance between that number and 0. So for example, the absolute value of 3 would be equal to 3 because it's 3 units. 1, 2, 3. Its distance from 0. Its distance from 0 is 3. It doesn't matter if it's in the positive or the negative direction. Distance is a positive quantity, always. And the absolute value of -4 is the distance between -4 and 0, which would be +4. Because -4, even though it's in the other direction, it's still a distance of 1, 2, 3, 4. 4 jumps from 0. It doesn't matter if it's the left or the right. So if we think about solving an absolute value equation, we say solve the absolute value of x is equal to 5. What we're trying to do here, and what this is saying this is written in the language of mathematics, but if I translate this to English, I would say to solve this equation means to find all numbers that are a distance of 5 units from 0. And there's 2 of them. There's 2 of them. And if we start at 0 and move a distance of 5 to the right, we get the number +5. And if we move a distance of 5 to the left, we also get a distance of 5 to the left. We get the number -5. So this has two solutions. If the absolute value of x equals 5, then the answer is, well, there's two answers, x equals 5 and x equals -5. Now, how does this apply to inequalities? Well, there's two types. There's greater than and there's less than. Right? With an equal sign, there's only one version, equal 5. But with inequality symbols, we could have a less than or a greater than. So I have greater than on the left, less than on the right. Now, what does this look like on the number line? This is going to tell us what to do when we're solving equations. Sorry, not equations, when we're solving inequalities. So if here's 0 in the middle. Okay, so let's look at the left first, over here. The absolute value of x is greater than 5. That means x is any number whose distance from 0 is larger than 5. Has to be more than 5 steps away, more than 5 jumps away from 0. So if this is exactly 5, this distance is exactly 5, between 0 and 5. But x has to be any number further away from 0 than 5. So it would be any number over here, any number above 5, going all the way up to infinity. But there's also other numbers that are a distance greater than 5 from 0. I keep saying the word distance. Absolute value means distance. So over here is -5. So also, all of these numbers to the left of -5, they are also more than 5 units away from 0. So we have two separate chunks of numbers here. We have the numbers where x is greater than 5, and we have the numbers where x is less than -5. But if we look at the one over here on the right, let's do the same thing. Let's shade the part of the number line that corresponds to the answers, to the numbers that make this statement true. X could be any number that is less than 5 units away from 0. Any number that is less than 5 units away from 0. So if 5 is over here and -5 is over here, it's got to be closer than 5 units. Closer than 5, closer than -5. So it would be all of these numbers in here. I'm going to use open circles everywhere because there's no or equal to symbol. This is why for the second problem, I introduced compound inequalities. That's for the between two numbers case. So x could be bigger than a number, x could be smaller than a number, or x could be between two numbers. In this case, x is bigger than -5, but also smaller than +5. Okay, this is important. This is how we solve any absolute value inequality. When you have an absolute value on one side and an inequality symbol, if you have the absolute value is greater than a number, you have to solve two separate inequalities. If you have the absolute value is less than a number, then you solve one single compound inequality. So I have two problems to do. Let me show both of them first. So number 3 will be the less than case. Absolute value of x plus 1 is less than or equal to 4. And then the last problem, the absolute value of 2x plus 8 over 2 is greater than or equal to 6. So we'll start with a less than problem, then we'll do a greater than problem. It doesn't, the or equal to doesn't have any effect on how we set it up. Okay, so absolute value less than a number. And this is always true, 100% of the time. If you have the absolute value by itself on one side, right? Now, if we had x plus 1 in the absolute value, plus 3 was less than or equal to 7, we got to get rid of the 3 first. You need absolute value by itself. So you'd have to, here, you would have to subtract 3 from both sides to get rid of the 3. So once you're at a point where you have absolute value by itself on one side of the inequality and a number on the other side, you set up a compound inequality. X plus 1 has to be less than or equal to 4. And that's what this is saying, less than or equal to 4. But because of what we previously talked about, it also has to be greater than or equal to -4. Right? This is using the absolute. So now we've used up the absolute value bars. We've removed them. So by setting up this compound inequality, we have done the absolute value part. We no longer have an absolute value in this inequality. Let me go back one slide. That's the whole point of what we did here and here. And this is how we remove the absolute value symbol from the inequality. Okay, so this one pretty easy in terms of it's only a one-step problem. We have to subtract 1 from both sides. Once we're at this compound inequality point, it's only one step. -1 from the left, -1 from the right, -1 from the middle, because we want to cancel off that +1 in the middle. So we get -5, -4 minus 1 is less than or equal to x, which is less than or equal to 3. So this is the answer. This is the answer using inequalities. We could also graph this. Okay. -5 is over here. +3 is over here. Close circle on the 5, close circle on the 3, and we shade between them. That's also the answer, written in graphing form. So we have inequality form, graphing form, and then the third way to write the answer. So this is basically saying the answer 3 different ways. The interval, starting with -5, ending with 3, bracket on the 5, bracket on the 3. And so this is how we solve all inequalities that involve absolute value less than. Now, if it's absolute value is greater than, we have to do something different. And I'll go back one more time. We have to do something different because if you look at what we've shaded down here on the number line, it looks very different. Here we have 2 separate regions of the number line shaded because of the greater than symbol. So when you have the absolute value of something is greater than a number, that number can't be negative, of course. I guess it could be negative in this case. The answer would be all real numbers, but the absolute value is always a non-negative number. It can't be anything below 0. But in this case, absolute value greater than or equal to 6, we have to set up two separate problems. Two separate problems. We've got 2x plus 8 divided by 2 is greater than or equal to 6. That's the original problem without the absolute value bars. We also have 2x plus 8 over 2 is less than or equal to. So we change the direction and change the sign, less than or equal to -6. So over here was like the part of the number line that was shaded to the right. Over here is the part of the number line shaded to the left on the negative side. And now we have two separate inequalities to solve. We no longer have an absolute value. And we could approach this a number of different ways. We could factor and cancel the 2 on the bottom, or we could simply multiply both sides by 2. And when we multiply by 2 on the left, that cancels the dividing by 2. Remember, fraction means division. So if we want to get rid of division, we use multiplication. So we have 2x. We have a plus 8. We have a greater than or equal to, and we have a 12. We're going to approach the other one the exact same way. Multiply both sides by 2 to get rid of the fraction. So on the left, those 2's cancel. And we have 2x plus 8 is less than or equal to -12. We want to get x by itself, right? So we got to get rid of that plus 8. And the way we eliminate the plus 8 is with a -8. So we'll subtract 8 from both sides. And we'll do the same thing over here. Subtract 8, subtract 8. So the plus 8 and the -8, they cancel. So we get 2x on the left. We get 2x on the left. But on the right hand, the first problem, 12 minus 8 will give us 4. On the other one, number 2, -12 minus 8 will give us a -20. Okay, so we're not going to get the same number. We're starting with the same number plus and minus, the 6 and the -6. We're not going to get the two same numbers on the bottom in our answer. But we're taking the same steps, though. Divide by 2 to get x by itself. So those 2's cancel. Same thing over here. Divide by 2 to get x by itself. So the 2's cancel. And we get x is greater than or equal to 2. And also, you can't have just one. The x is greater than or equal to 2 is only half of the answer. We also have x is less than or equal to -10. So just like we did with the previous problems, I'll graph the answer and also give the answer in interval notation. So 2 is somewhere to the right of 0, and -10 is somewhere over here to the left. X is greater than or equal to 2. So we have a closed dot, shaded dot, and we shade everything to the right. And then x is less than or equal to -10. So the equal to is the dot, and the less than is the shading to the left. Right? This answer to the right goes on in the direction of positive infinity, and the answer on the left, the part of the answer on the left, goes on forever in the direction of negative infinity. So when we set up our intervals for interval notation for our answer, we have two separate intervals. The part of the answer on the left is going from negative infinity up to negative 10, including negative 10. But the infinity always gets a curved parenthesis because infinity is not an actual number. The part of the answer, the shaded green area of the part of the line on the right, starts with 2 and then goes forever in the direction of positive infinity, including 2 up to infinity. So that's our answer, but we have to combine, connect these two pieces. So we could say the word and like this, all the numbers from negative infinity up to 10, including or negative 10, and all the numbers from 2 to infinity. But the mathematical notation here for intervals, instead of using the word and, we use union. And that's our union symbol. That union symbol we discussed way at the beginning of the course in section P.1 when we talked about sets, the union of two sets. Right, so our answer could be written as a pair of inequality symbols. It could be given as a shaded part of a number line, and it could be also given as interval notation. Just pay attention to the directions in the problems that you're doing. The problem will normally say, it doesn't here because I was doing it all 3 ways, but if you're doing a problem, it might ask you to solve the inequality, give the answer in interval notation, or it might say, give the answer in inequality notation, or it might say graph, or it might say give 2 of them. Just pay attention to the directions in the problem. Okay, that does it for this video. I hope it was helpful.